A hydrate is simply a substance that has H2O molecules embedded within its structure. When you heat up a hydrate, those H2O molecules vaporize, leaving behind the anhydrous salt, which loses mass because the water has gone away. So the formula of a hydrate is typically written with the traditional chemical equation. So in that example of that video, that was copper sulfate, so CuSO4. Copper is a 2 plus, sulfate's a 2 minus, so the subscripts are just 1. And then since it's a hydrate, we put a big fat dot, which does not mean multiplication. That particular hydrate's what's called a pentahydrate. And so penta is the prefix for 5, and hydrate just means water. And so this would be the formula for copper 2 sulfate, pentahydrate. So when you face a problem that's talking about a hydrate, typically what we're trying to solve for is, what is that number? So the one I'm going to do for you as an example comes from problem 1 of the document that's attached with this video. So there are 10 problems plus a bonus problem there at the bottom. I'm not going to grade this, but this is great practice. I'm also attaching the answer key with this so that you guys can practice a couple, check yourself, and then if you have any questions, you can see me for that. So problem 1 says we have a 15.67 gram hydrate of magnesium carbonate. So this is Mg 2 plus, carbonate is CO3 2 minus, and it's some hydrate. So we don't know what this number is, but it's a hydrate, so it's got an H2O. So this is our unknown thing. And we heat it up. It doesn't decompose the magnesium carbonate, and we drive off the water. So when we heat this up, so let's say plus heat, the water goes away, and all we have left is just magnesium carbonate. So it says the mass was reduced to 7.58 grams. So this thing is 7.58 grams. What is the formula of the hydrate? Well, the first thing we can do to figure out is figure out how much mass was lost because we drove off the water. And that's really easy. That's just subtraction. 15.67 is how much it was when it had the water in it. 7.58 is the mass after the water was gone. And by subtracting those two things, you find that the difference is 8.09 grams. Well, don't confuse what this 8.09 grams represents. This is the mass of the water that left, because this was the mass of the hydrate. This was the mass of the anhydrous salt, which means this is the mass of the water that was lost. So those are the two important pieces of information right there. Because this number, or this number that we're trying to find, is simply a mole ratio. If this is a 1, what is the ratio of H2O for every one of those? So we're going to make a conversion of everything into moles. So the first thing I'm going to convert is the magnesium carbonate. So I got 7.58 grams magnesium carbonate. I'm going to convert that to moles by dividing by the molar mass, which is 84.313 for every 1 mole. And when I calculate that out, I find that that is equivalent to 0.0899 moles of magnesium carbonate. So that's phase 1. The next thing I need to know is how many moles of water is represented by 8.09 grams. So I'll do the same thing. 8.09 grams of H2O. Divide by its molar mass, which is 18.015 per 1 mole. And I find that this is 0.449 moles of H2O that was lost through heating. Now, if you recall, when we're doing ratios, we divide every mole by the smallest of the moles. So 0.0899 is smaller than 0.449. So I'm going to take 0.0899 divided by 0.0899, which obviously gives me 1. Then I'm going to take 0.449 divided by 0.0899. And when I do that, I get 5. And so what this tells me is that the magnesium carbonate is in a 1:5 ratio with the H2O. So that is the formula of this hydrate. So step 1, do the subtraction to figure out how much water was lost through heating. Step 2, convert the mass of water and the mass of your anhydrous salt to moles by dividing by their respective molar masses. Step 3, divide both of their number of moles by the smallest between the two, which should be your anhydrous, because we're trying to force that guy to be 1 so that we can figure out what this number is. So you divide them both by the smallest, and then that tells you the ratio. And so then that value lets you know what is that number for the hydrate.